Let us consider one more example on Coulomb's law. Into this problem, it is said point charges of 1 microcoulomb, comma, plus 1 microcoulomb and minus 1 microcoulomb are placed at the corner A, B and C of an equilateral triangle ABC of sides 0.3 meters. Calculate the resultant force on the charge at B. To find out the solution, let us first consider an equilateral triangle. So an equilateral triangle of vertices ABC has charges of 1 microcoulomb at point A, another microcoulomb at point B, and minus 1 microcoulomb at point C. I am writing those values as 1 10 to the power of minus 6. Further, QB is at a distance of RAB, is at a distance of RCB, and the distance of RCA all are same. That is, charge QB is at the same distance from the other three charges, and it has to be from the other two charges, and it has to be at a distance of 0.3 meters. So let us first find out what should be the force on charge B due to A. Using Coulomb's law, force on B due to A is given as 1 upon 4 pi epsilon naught QA QB upon RAB the whole square, where FBA is equal to 9 10 to the power of 9 into 1 10 to the power of minus 6 into 1 10 to the power of minus 6, which are the charges on A and B, upon the square of the distance between the two charges, which is 0.3 the whole square. On simplifying, you get an answer which is 9 10 to the power of 9 into 10 to the power of minus 12 divided by 0.09, or we get force on B due to A is equal to 100 into 10 to the power of minus 3 Newton, and the force between QA and QB should now be along the line AB. Hence, FBA is along AB. Further, now let us find what is the force on charge B due to C. Remember, the charge at point C is a negative charge. So let us find what is the force acting between them. So the force on B due to C is 1 upon 4 pi epsilon naught charge at point C into charge at point B upon square of the distance between the two charges. Therefore, the force between charges B and C, or the force on B due to C, is given as 9 10 to the power of 9 into 1 10 to the power of minus 6 into 1 10 to the power of minus 6 upon the square of the distance, which is 0.3 squared. Remember, when we're calculating Coulomb's law, or whenever we're using Coulomb's law, we are only considering the magnitude of the charges. We are not considering the polarity of the charges. So in this case, we will only find in which direction the force is moving. That is, the polarity of the charges will help you let us know whether the forces are repulsive or whether they are attractive. So on simplifying the above relation, I get 9 10 to the power of 9 into 10 to the power of minus 12 divided by 0.09. Almost a similar answer what we have got previously. So force on B due to C is 100 10 to the power of minus 3. Therefore, the force on B due to C is an attractive force which is along BC. Hence, we have found out both the forces, that is FBA as well as FBC. Please make a correction into this force, that is the force between B and C, should be given as FBC. It is wrongly written as FBA. Now, the forces between FBA and FBC can now be found out using vector law addition, or you can even call it as parallelogram law of vector addition, where if we construct a parallelogram between both the forces, we find that the resultant is the diagonal drawn from the point from where the two forces are coming. Therefore, the resultant is given as root of p squared plus q squared plus 2pq cos theta. Therefore, F is equal to root of FBA squared plus FBC squared plus 2FBA into FBC cos theta. Remember, theta is the angle between both the forces. So to find this angle between both the forces, we know it's an equilateral triangle. So angle ABC is equal to 60 degrees. It means the straight line AB when extended further should give you the remaining value, which is 120 degrees. Therefore, theta in this case is equal to 120 degrees. On substituting the values, I have resultant force F is equal to 100 10 to the power of minus 3 the whole square plus 100 into 10 to the power of minus 3 the whole square plus 2 into 100 into 10 to the power of minus 3 into 100 10 to the power of minus 3 into cos of the angle between both of them, which is cos of 120. It is known that cos of 120 degrees is minus half. So on simplifying, I get it as minus 0.5. Please substitute this value in the above relation. You should get F is equal to 10,000 10 to the power of minus 6 plus 10,000 10 to the power of minus 6 plus 200 into 10 to the power of minus 6 into minus 0.5, which on simplifying gives you F is equal to 200 10 to the power of minus 6 minus 10,000 10 to the power of minus 6. Sorry, it should be root of 20,000 10 to the power of minus 6 minus 10,000 into 10 to the power of minus 6. Therefore, F is equal to 10,000 into 10 to the power of minus 6, where F is equal to 100 into 10 to the power of minus 3, where we have found out what is the magnitude of the resultant force. Now, since we have found out the magnitude of resultant force, we have to now find out what should be the direction of the resultant force. Let us assume alpha is the angle made between the resultant force and one of this component, where I am taking FBA as one of the component. So let alpha be the angle between the resultant force and FBA. Using the formula, tan alpha is equal to q sin theta upon p plus q cos theta. We get tan alpha is equal to f and bc sin theta upon FBA plus FBC cos theta. Please remember, when we are considering theta, it is angle between both the forces, which should be 120 degrees. So please substitute value for theta in the above relation. You would get 100 10 to the power of minus 3 into sine of 120 degrees divided by 100 10 to the power of minus 3 plus 100 10 to the power of minus 3 into cos of 120 degrees. Now we know sine of 120 degrees is root 3 by 2. That is wrongly given as minus root 3 by 2. Please consider it as root 3 by 2 and substitute that value over there. Cos of 120 degrees is minus half. So cos of 120, which is minus half, please substitute as minus half into this relation, and now simplify this whole expression to see what you will get. So I should now get my answer as tan alpha is equal to 50 into 10 to the power of minus 3 into root 3 divided by 100 10 to the power of minus 3 minus 50 10 to the power of minus 3. I have simplified both the above relations, and now I get tan alpha is equal to 50 10 to the power of minus 3 into root 3 divided by 50 10 to the power of minus 3. So I'm left with a value where tan alpha is equal to root 3, or alpha is equal to tan inverse of root 3, which ends up giving an answer of 60 degrees. Therefore, alpha is equal to 60 degrees. Should be the direction with FBA, that is the direction of the resultant force with FBA.